Hello, everyone. Welcome to our Unit 7 discussion here in ST125. So today we're going to be talking about surgical instrumentation, inspection, and repair. So here are your assignments for this week. You do have a couple bigger exams, knowledge check type things here towards the end that are 100 points. This Unit 7 assignment is 90, so I know it seems like a lot here towards the end, but we're just kind of getting things wrapped up. So just to look ahead, you also have this Unit 8 assignment down here. That is just a discussion post that you do not have to respond to a peer to. So it is just your post, reflection about the quarter, what you've learned, summarizing basically each unit. And that is due Tuesday. So it is a shortened week next week. So there won't be a video or anything extra like that. So just keep that in mind. Just work on getting everything turned in that maybe you haven't turned in. If it's a 0 in the grade book, you can still go back and turn that in. Okay. So here are your objectives for this week. You're basically learning about different instrumentation handling, safety handling, and how to prevent instrument damage. We've talked a little bit about that in the past, and what can be done to fix those things, the troubleshooting, how do you repair surgical instruments, that sort of thing. So, for example, why is it important? Why do we need to inspect instruments every time they come back to SPD? Well, really, the bottom line truly is patient safety. That's why we do what we do. That's why we do anything in healthcare as patients, right? So keep that in mind every time you get a tray of instruments back, because this the surgeon, the patient, they're all depending on you to make sure that they're in good working order to go back to the OR for the next case. So if something comes back to you, maybe it wasn't even tagged, maybe the staff upstairs in the OR wherever didn't notice that something was broken. Maybe it got broken in transport. Who knows? That happens. They depend on you to pick up on those things, to pay attention to detail. That's super important before they go back to reprocessing to be used again. So it's important for patient safety. We want to increase efficiency during the case. So for example, if in the middle of the case, the surgeon says, the tip of this bipolar forcep, which I have pictured right here in blue, maybe this bipolar forcep here on the end is broken. Now we have to wait to go get another one. The circulator has to go hunt one down. Maybe it's not readily available. Maybe there isn't another option. Really can cut into the efficiency of the surgery, what the surgeon can do. So again, that kind of goes back to patient safety, right? It's also cost effective to keep up with instrument maintenance, preventative maintenance. These instruments, as it comes to no surprise, I'm sure, are not cheap, okay? Especially when you have multiple trays of instruments that you have to keep up with. So it is expensive, and we obviously want to make it last by taking good care of it. Um, so you can actually increase the life of the instrument by, some even say, like up to 20 years if you take good care of the instruments, preventative maintenance. Um, you're handling them correctly. The OR staff is handling them correctly. They're not misusing them for things they shouldn't be, that sort of thing. Really can extend the life of the instruments. So keep that in mind. So what are you looking for every time you come in contact with an instrument? What should you be looking for on every instrument? It seems like a lot, but it's kind of like it'll become second nature, I guess you could say. So you're going to look for things like chips or cracks anywhere. Usually the problem tends to occur in the using end, but not always. So don't just focus on the end that gets used on tissue, whatever, for example. Um, you gotta look everywhere, even at the locks. You're gonna look for burrs. Those are like little pieces of metal that maybe they got chipped on something or got something got knocked up against it. So maybe there's a little metal piece sticking out. If that gets, put in contact with very delicate tissue, that could damage that tissue. It could tear it. It could cause a bleed in a vessel. It could even cause nerve damage. I know that, that seems extreme, but that's what can happen with instruments that are not functioning properly. It could lead to patient injury or tissue damage. You're going to be looking for missing pieces. Let's say you have a valve bore retractor. You know your facility counts that, let's say, as 8 pieces. Are they all there? Did it get lost in transport? Did it get thrown away? That happens more than we care to admit. Things get thrown away, um, wrapped up in the drapes or whatever. So always be checking for missing pieces. If not all the pieces are there and you have to have all, let's say 8, for it to be usable, um, you have to set it aside, find a missing piece, whatever you got to do, make sure that that's ready to go. Functionality, a lot of this really could be related back to functionality. Is it usable? I know that seems kind of silly. So um, you have to know what these instruments are, their names, and what they're used for if you're going to be working in sterile processing. Otherwise, how do you know if it's functional? If you don't know even what it does, you're not going to know if it's functional. Okay. The coating is intact. For example, back on that, I can go back on this bipolar. This is like a blue insulation coating. So your laparoscopic, anything that carries an electric current will have a coating or like an insulation coating to keep the electrical current inside. So is that intact? If there's a break in it or a hole, that electric current could escape and cause patient tissue damage. It could cause electrocution of even the person using it. So that is super important to double check those. And while I'm here, I forgot to mention that this instrument here in the corner is called a handheld Meyerding, a Meyerding retractor. So we use that often in like back cases, back spinal cases. It's tiny little serrations of teeth that could also be chipped. So you want to check those. But anyway, back to this. Um, so the coating, rust spots, things that could cause rust spots or pitting is if maybe these instruments are getting soaked in saline. You do not want to soak instruments in saline. That causes rust and pitting. Um, it could be buffed out by an instrument repair tech, maybe. But it could also just damage it to where it's not usable. It could, you know, cut into the lifespan of the instrument. It could harbor bacteria. You don't want that. So do not soak instruments in saline. Do the ratchets lock? So for example, in this is a Bacchus towel clamp here on the left side. There's always the box lock ratchet that keeps it shut. Every now and then they get maybe a little out of alignment, out of whack, and they don't stay shut. You don't want that. So anything that has this type of ratchet has to ratchet shut. Needle drivers, do they hold a needle appropriately? Sometimes the serrations on the end of that needle driver get worn down, or they could be chipped as well, and they won't hold a needle properly. Nothing will frustrate a surgeon more than a needle driver that is not holding a needle properly. It's ineffective. They won't be able to suture with that. Do the teeth align on clamps and forceps? So for example, in this right corner picture, this is called a Bonnie forcep. It's very similar to a Ferris Smith forcep if you've seen a Ferris Smith. The ends are the same, but the handles are a little different. But it has a really big, heavy tooth that needs to align. Like this top one goes into the bottom for picking up on really dense, heavy tissue. So do they meet in a way that the tissue can be grasped in between those teeth? If they don't align, it's not, again, functional. So this little tooth at the top could be chipped. It could be bent out of alignment. So always check for those things. Visibility and endoscopes. Can you see down the scope? Those hysteroscopes that we mentioned a couple weeks ago, those you can just look through the end of them without having it hooked up to a monitor or a screen to see if it's visible. Because those are really delicate and can easily be broken along the shaft of the instrument. So you can hold those up and see. All right, so I do have a video just on what an instrument repair person is looking for and what they would do to fix some of these things, because I wanted you to see that aspect of it as well, because it's easier to see, I think, sometimes than just kind of talking about it. Um, and then this second video, if you wanted to like pause and write it down or type it in, this is a really good. It's a little bit longer video about instrument repair and what is needed and go, the different steps. It was just a little bit longer. It's probably like closer to 30 minutes that I didn't, want to sit here and show you at the same time. But this one here I'm going to pull up and it is not quite as long, but it does show you the different things to look for. So let me pull that up here. Here it is. So this should show you how to repair some of those things we talked about. All
Welcome to GSI's Surgical Instrument Repair Training Program. This program is designed to equip you with the knowledge and skills to perform basic adjustment to ring handle forceps, tissue forceps, skin hooks, and small rake retractors. You will also be instructed on the use of specifically designed equipment and tools needed to perform these repairs. It is important that you understand how these instruments work and the names of the different parts of each instrument. Although these repairs are relatively simple, the techniques used are specific and the attention to detail is important. In preparation for this training, you will need to have available several ring-handled forceps, tissue forceps, skin hooks, and rake retractors. A small plastic set will have these instruments. Pause and review the information in this program at any time if needed. Section 1. Adjustment Station, Components and Tool Function. In this introduction to the adjustment station, its components and tools will be identified along with an explanation of their function. The specific tool usage will be demonstrated in detail in the preceding training programs. Key lock and screw press. The lock is provided to secure the tools in the bending station. The screw press is used to tighten the box lock of ring-handled forceps. It can be used as a clamp to hold instruments for adjustment or examination. Backlight. This LED light, operated by an off-on switch located on the side of the unit, is used to backlight surgical instruments for inspection. The magnifier is mounted on a flexible arm and is used to inspect surgical instruments for flaws and to assist in proper alignments. Chain nose pliers. These pliers have jaws with a flat inner surface and rounded exterior. They are used to firmly grasp and bend specific parts of misaligned surgical instruments. Round nose pliers. These pliers have two cone-shaped jaws that are used to restore the curved tips on skin hooks and small rake retractors. Box lock spreading pliers. These pliers are adjustable and have two specially designed jaw teeth that are used to spread the stiff box lock after instrument milk lubrication does not eliminate the stiffness. Screwdriver spreading tool. This screwdriver is used to tighten large and small screws that are found to be loose. It has a reversible shank and 3 sizes of flat heads to fit most screws. It also has a sharp pointed tip that is identified with a colored band. It is used to spread the tip on ring and tissue forceps. Point file. This file has a slot running its length and is used as the first step to sharpen or restore the shape to the points of skin hooks, rake retractors, towel clips, and other sharp-pointed instruments. 3-stage buffing deburring stick. This tool has 3 buffing surfaces and is used to restore the finish on stainless instruments. It has 3 grits. Pink is coarse, white is medium, fine is gray. The 3 stages of polishing are used to restore the finish to the points of instruments after reshaping with the point file. It can also be used to remove scratches that may affect instrument function. Instrument milk. This lubricant is applied directly to the joints of surgical instruments to loosen sticking or stiff joints. When it's worked into the joint, it acts to dissolve any embedded material that can cause instruments to bind or stick during operation. Triangle file and diamond file. These files are used to remove metal from surgical instruments. The triangle file is used to restore the teeth on tissue forceps and the teeth on the jaws of ring forceps. The triangle file and diamond file will be used to remove burrs. The diamond file is used for heavier metal removal. Note that the triangle file only removes metal when it is pushed in one direction. Tissue forceps tip spacing gauge. These two gauges are used to quickly check the spacing between the teeth of tissue forceps with the instrument fully open. Note the position of the 5-inch mark on the top of the bending block. Tissue forceps that are 5 inches and shorter are to be measured on the left gauge. Tissue forceps longer than 5 inches are to be measured on the right gauge. Bending block. The bending block is used to hold the surgical instruments firmly while opposing pressure is applied to the instrument so that it may be bent to its correct position. It has several slots that are different sizes to accommodate different bending needs. Power input. The power supplied to the backlight is located on the side of the upper case. The hospital-grade power cord plug connects to the fused off-on switch receptacle.
All right, so hopefully that gives you a little bit better insight as to, what goes on once you decide, yes, this needs repaired. Now, keep in mind, that could be something that you as a sterile processing tech could get into as a job. Some facilities, if they are a larger hospital, might do those repairs on site and have someone who has specialized trained in instrument repair to do those types of things. Other facilities will have a company that they've outsourced come to their facility, and all those instruments that you've set aside to be repaired, they will work on. Maybe they come once a week or a couple times a week or whenever that is. That could be something that you could get into if that interests you, if that's maybe the path that you would want to take. That is totally possible. So there are different companies. There's a lot of companies that will do those types of things. So just kind of keep that in mind. All right. So if you have any questions, please don't hesitate to reach out. I know we're getting close to the end of the quarter. There's usually some burning question about an assignment or something that maybe you've had. Could you make it up or whatever? Just email me, mludwig@herzing.edu, and we can get that sorted out for you. All right. Have a good day. Bye.